somebody must have shown. I want to highlight a very important thing. Generally, we see this picture and just say alpha can be cut off easily, beta can be cut off with bit difficulty, and gamma can be cut off using lead. But important thing here is, if you see the beta, now you can see beta cannot penetrate even the thickness of the plastic. Now, you can assume, I think most of you can understand Hindi also a little bit. So if you can see that if I put beta in a container, it will not be able to come out. It will deposit all its energy in the container itself. So this gives me a clue that if I want to kill some bacteria, if I put a beta into that, it will deposit all energy in that matrix itself and it may kill the bacteria. Now come to the gamma, the lower one. You can see it can penetrate through plastic, only lead and concrete can stop it. So if I put again a gamma source in a container, the radiation will be able to come out. Suppose some radioisotope which emits gamma is inside my body, from outside it can be detected. Now these properties of radiation are utilized for in a big manner in healthcare. And in my other slides, I will show you further these things. Now, how radiation is able to make changes in the matrices or materials which are irradiated. Just don't see other things. Just see that if I take any organic system and irradiate it, it will generate radicals. Now, as a student, we know if the radicals can be generated, chemistry can be done. Chemistry can we can do all chemical changes in the medium by using means you take a matrix, just irradiate it, it will generate radical, and by depending on your wisdom how you use it, those radicals can be carefully tailored to bring out the necessary changes in the matrix. Now, this generation of radiation can be used for many things, from polymerization, cross-linking, other. I will tell you what are these things, killing pathogens in cells, even inducing color in hardest matrices like diamond. Another important thing is if I take water and just irradiate it, just don't see other things. The H2O irradiated generates just if मैं पानी ले लूँ और उसको irradiate कर दूँ, just simple irradiation without adding anything I will be able to generate the most strongest oxidizing agent, OH radical, or the reducing species AE aqueous in the medium. Two important things I have told in the last two slides, that it generates radical in any organic medium. Radiation can generate radical in any organic medium. If I irradiate water, I can get OH and E aqueous, means again I can do chemistry in the medium. And because if something is there, if suppose the organism is there which has water, if I irradiate, it will generate radicals and they can damage the DNA, which this property of radiation can be used to remove the pathogens from the medium. Another important thing is the ratio of the matrix which you take, energy deposit will be proportional, according to the chemistry can be changed. Now, food and agriculture, yesterday one of my colleagues has spoken on food and agriculture, so I will conveniently skip this part. I'll go to next one. Now, healthcare, prevention, diagnosis and therapy, the radiation and isotopes are used in healthcare in all these three. I'll give you one example of each here. See, so what are radiopharmaceutical? Radiopharmaceutical is something called, just give me a minute please. Sorry, it's not happening. So you can see, this is the yellow and black, this is the radioisotope. Now if I put this red thing which has been shown, this is the carrier. And suppose this green is the target side where it has to go. So if the isotope is coupled to suitable carrier, it can be directed to, suppose there is some tumor is there, it can be directed there. This is what is called targeted therapy. Now as I told you, this isotope will give some form of radiation. So if that it goes to that target, and if it deposits energy there, you can see that cancerous tissue or something or pathogen can be made to die by using this radioisotope coupled with the carrier there. Now, if I want to diagnose the things, diagnosis यदि किसी को कुछ medical problem है, तो उसको if I give an isotope, the radiation should come out. The radiation should come out for detection. It means what? The radiation should give out gamma. As I told in the beginning, gamma can come out of the body. So for diagnosis, isotopes which give out gamma will be used. And for therapy, where the isotope has to deposit energy in the matrix, that will be used. So our colleagues from radiopharmaceutical, depending on what is the target means organ or tissue, they like 99 technetium is an isotope. Now it can be coupled to, I showed you there a red tailor in the earlier name. So you can, one can find out this type of to couple those things and then target depending on where the cancer or the pathogen is. You must have heard about thyroid. Very simple thing is a person is given 131 isotope, 131 iodine, which gives gamma and beta both. Now, as I told you, what gamma will do is, gamma we will be able to detect from outside that where that 131 isotope is sitting, and the beta will be able to get the thyroid, hyperthyroidism or hypothyroidism, whatever is there. BRC has also developed yttrium-90 based glass microspheres. What happens is this yttrium-90 gives beta. Now for liver cancer where there no surgery can be done, this 90 yttrium which emits beta is injected into that artery and it blocks this size is very important here because it blocks the blood circulation to that cancerous tissue, and that is how the cancer of the liver is cured. Other important thing is, again, this was I told you about the therapy and diagnosis. Other thing was sterilization is also very important. Sterilization means, suppose I use an injection or somebody gives me an injection to me because of some my disease, it cannot be as such used for the other patient because that will carry my disease to the other person. So the things have to be sterilized. The conventional way of doing sterilization is heating, dry heating or steam heating or some gas sterilization. But then there are stringent conditions to do that. In radiation sterilization is very easy. You take the material as shown here in this box, irradiate it, and the product is sterilized, and it remains sterilized as long as it is not open. So I think this, you can see how easy it is using radiation to sterilize the things and how it will help in the prevention of the drugs. Similarly, in DNA, if you irradiate, as I told you, what happens, the pathogen, how the pathogen gets deactivated, the radiation damages the DNA, and if the DNA, we know if the DNA is not there, it's damaged, no multiplication will be there. That is how it is taken care. Let me go to the second topic, industry. Now today, regarding industry, I will be speaking on polymer. I am a person of polymer. So why polymer? See, if you see the human evolution, it started somewhere in Stone Age, Bronze Age, Iron Age, and today, if the later historian write, maybe this will be polymer age. Because the material which is being used as on today is means in all fronts of life is the polymers, starting from a toothbrush to cars and jackets and shoes, everything is polymer. So that's why I will speak something on radiation effect on polymers. Maybe the audience will may be able to appreciate that how radiation has an important role in processing of polymers. Now, from our school level, if you recollect, we were told that if you want to polymerize something, take a monomer. Monomer is a chemical species which can form a chain molecule. We have to use initiator to that and then heat the things to get a polymer. Now, what is the use of this initiator there? It generates radical. Heat this initiator, it generates radical like R dot shown here. Suppose I want to polymerize styrene, this R gets added here as shown here, and that's how the polymerization goes on and on and on. Now the important thing here is, suppose I wanted to make a pure polymer out of styrene, this radical got added here, which was not desired. Secondly, from chemistry, as a chemistry student, we also know that if I use say some chemical, say initiated into matrix to polymerize, there will always be residual initiator which will remain back. And over a period of time, this initiator will not remain there, it will come back. Suppose this polymer which I made was to be used for eye contact lens, that initiator over a period of time will come out, cause irritation to here, and if the polymer is used to be contact with the human body, that may cause side effect. So for this type of polymer which are to be used in human body contact, it is advisable and it should be recommended that radiation should be used so that the polymer is very clean and very ultra clean. Now, just I will give, before going to polymer, I will give a very example of polymerization. Now, as I told you, for polymerization, generally what we have the impression about that high temperature is required. But here I will show you something, even at some room temperature, radiation can. Just see the slide on this on top left. This, see, when we have some medical problem, we go to the doctor and he says take a drug. So why he said that take after every 8 hours? You see, whatever the drug is taken, the drug concentration goes up. And because our excretion system starts working, it starts eliminating from the body. So after here, we have to take second drug, so drug concentration again goes up and comes down. So there is a fluctuation drug level. Ideally, the drug should remain in the therapeutic window. Therapeutic window means the concentration of the drug which will cure the disease. If it goes beyond that, it is toxic level. Below this, it should be therapeutic level. So ideally, the drug concentration should be something shown in red. The drug concentration should go up and remain in the therapeutic. Now how to do it? There are many ways. One of ways is this thing here. Suppose I take a monomer.
Side blockages. Sir, I'm oh, connection lost. The koi diyo tu connection lost hai. Koi diyo. Sir, koi diyo. Reconnect again.
Now these are not more speeds like of thing. Now if I put in it. Hello? Hello? Yeah, can I continue?
Yeah.
Okay. So if I see the drug solution, it swells. Now if I take this drug will sit this red part, you are seeing the drug will sit there and in the polymer also. Now if this swells, you see the first the drug will come out of the red zones. This will be the jump in the drug concentration. Later on the polymer, the drug will come out from the polymer. So the drug concentration goes up and remains in this way. So this is possible because the radiation can cause polymerization at low temperature, as I showed that the polymerization can happen at minus 70 centigrade. Let's move to the polymer. We know that when you must have seen when we eat Maggi, to remove a Maggi string from the plate, it requires a lot of much strength comparatively. So it shows that if the polymers are entangled, if the chains are entangled, we require more strength to remove it from the matrix. So this property, if we can do intensely, this can be a good source. The polymers, you know, they have a variety of properties I listed here. I am not going to speak on that part. So if I take a polymer, irradiate it, I can generate radical. Now what one can do is, either I can, this radical, we know radicals are very active species. One radical of one chain may react with the radical of other chain, and these chains can get cross-linked, may link to each other, which is called cross-link. You know, remember, this is a covalent linkage between the chains. One cannot easily break. Second thing is, because the long chain molecule, we can either break into smaller pieces, which is called degradation. Means उसको छोटे-छोटे टुकड़ों में तोड़ सकते हैं. एक third part is, on an existing polymer, this blue one shown here, we can grow another polymer after that. I will give example one each of this. Now, what happens if the polymer को जब cross-link कर देंगे, suppose this in black, the polymer chain is shown, the two different polymer chains are shown. If I cross-link it, shown in red here, you can see if I apply force like here, applied here, so there are 5 chains, apply force. The force will propagate from one chain to other to third to fourth to fifth. So it will be very difficult to break. Similarly, the porosity, the small molecule now is shown in blue here. Now we have changed the network, it will not be able to come out. So we can increase the mechanical property, we can decrease the porosity, and thermal stability also. Thermal stability increases because why? If we heat it, if one chain wants to flow out, other chain will not allow it to flow out. So by irradiation, we can improve the thermal properties also of the polymer. What happens, as I told you, the radicals see each other and they form a crossing between each other chains. Now let me give an example. You must have seen the cables and our cable. You must see this type of pinholes or these bulges on the polymer chains. Why it happens? It happens because when the polymers are crossing, lot of chemicals are added to them. Over a period of time, these residual chemicals generate gases that causes these pinholes or this type of bulges on the matrix. So ideal way is what you cross-link the matrix so that there are no chemicals into that. Just the example which I gave. Just to give an example of train, the railway track, the bogie which you see, it has 30 years of age, and after every 10 years this cabling has to be changed. Or you can think of that if this bogie goes for all these changes, it will be there for 3 months for all these changes. And its lifetime is 30 years, so every 10 years it has to be changed. So in a lifetime, 3 times this cable has to be changed. If I use irradiated cables for this, as I told you, for irradiation we don't have to use any chemicals. This is the means we have done some work for electron beam irradiation of cables. Just we have to see how properly the cables can be uniformly cross-linked, and then if we use in these railways and those things, only one in lifetime this cable is put and it will remain there for 30 years. It saves lot of energy, lot of time, and of course they have high operating temperatures. So this has So this we did work for the locomotive of Chittaranjan, and they are very happy now. Now it is a recommendation from there are recommendations that for all railway, defence, and this communication industry, the cable and wire should be preferably radiation crossing, so that they have a long time. Another important thing is you must have seen now there is in the market non-stick cookware. Why it is so prominent? Well, it has a coating of Teflon on that. Teflon, it has nothing sticks to it, means it has low surface energy. But have you ever thought, whenever this type of things are made, it will generate a waste also. Now, like this amazingly get some packaging like this, no, or Teflon waste which is generated, it is equally inert. What will happen to that? So we thought of working in that direction. Teflon is chemically inert, nothing sticks to it. If you burn it, chlorine will be coming out. So the waste disposal of Teflon or something like polyurethane film like this is a bit difficult. So can we do something for that? So as I told you earlier, I told you that polymer can be crossing. If Teflon is taken and irradiated, it can be changed into a powder. Now important thing, remember that if I take sodium chloride, a big part, if I break into pieces, the molecular weight doesn't come down, only the size comes down. By irradiation, you can decrease the molecular weight because radiation can go at a bond level. At the bond level, it is able to break, and this low molecular Teflon powder, after conventional grinding, can be used as a lubricant. It has a waxy feel. Marine atmosphere के लिए paints बनाने जहाँ saline atmosphere है, in that this powder is used. And self-cleaning coating. Nowadays, you must have seen in our sofa sets, if their water falls on there, it doesn't stop there. It just flows away. It is because of self-cleaning coating where this Teflon powder can be used. This is how the molecular weight varies depending on the size of the hose even. Another important thing is grafting. This all of us know. Our farmers were doing for mango. वो क्या करते हैं, मैंगो का ट्री लेते हैं, उसमें एक दूसरा मैंगो का पार्ट डलाते हैं, which gives you big fruit. Aim is what here? They want to get a plant which gives you good mangoes, but it doesn't fall easily. So root stock should be good, and the fruit also should be good. Something similar can be done with polymers. We take a base polymer, say Teflon. I will give you an example of that. Teflon I told you is very inert. All of us know nothing is stuck to it. But I will show you later side that we were able to graft something on this and then use it for removing dyes for the paint. Take Teflon, do grafting. If you want to know the chemistry behind that, you can refer to our papers or I can give you reference to that. So you can see that Teflon was grafted and you can see we were able to use it for absorption of dye. So what was the aim over here was to use a waste, absorb Teflon waste, and treat the effluent from after the waste from industry and try to pick waste dyes from there, so that the water, the dyes are not there in the effluents. We did the same for this polyurethane foam also, and we can find that the dyes can be removed. The references are given in the slide below. You can see it required. Based on this grafting, we have put a plant at Jaipur, which is a cellulose-based metallic grafting. It is being tested at the industrial level now, again for removing the dyes from the industrial level. Now, let me move to the other challenges. Till now, I have told you two things. One is the healthcare, other is the modification of polymers, and then there is challenge in the urban management if we can address using radiation. Chairman, how much time do I have now?
Sir, how much time?
Hello?
Sir. 15
Hello?
minutes. Tell 15 minutes बोलो भाई. अब बोलो ना उसमें.
Hello?
15 minutes. 15 minutes.
Okay, thank you. So there are challenges in urban management. We all from rural area want to come to the cities. Why? We feel there are more economic opportunities are there. Desire for living conditions are better. That's our aim. And the projections say that by 2030, apart from Delhi, Mumbai, Chennai, and Calcutta, we will have 4 new mega cities. So everybody wants to move from the rural area to the cities. And it is also, it should be everybody wants to go ahead, and he should not be restricted for coming. But when they move to the city, there will be challenges for the agencies who have to take the urban agencies who have to take care of the cities. There are many challenges for them. 2 of them are very important, which are shown in red here. The pollution and the waste management. Waste can be of many types. Means like our homegrown waste. Here today I am talking of the waste which is generated from our toilets or the grey bath from our household activities, grey water, we take bath, we wash clothes. So what are the waste generators here? What will happen to that? Big people, many millions of people coming, and this waste will be a huge one. Now what happens is whatever waste is generated from our houses, it goes to sewage treatment plants, and then water is discharged to the water bodies are nearby, and the solid part is the sludge. Now presently what is the other incineration is done. Now if you incinerate it, what will happen? The gases will be generated and air pollution will happen. If you put it in landfill, you are wasting the land. If there are water bodies nearby, we are polluting the water bodies. So there should be an efficient way of taking care of this solid waste. And another important concept is the STP are generally mentioned in the how much capacity, the 100 million liters per day. So if a STP has 100 million liter day capacity, it will generate about 2.3 ton of solid sludge. Every 100 ML will generate about 2.3 ton of this solid sludge. Another important thing is, see, remember that whenever we are, whatever is grown in our farms and villages, when it comes to in the form of bags of rice, to us, we eat it, it gives us energy, and the remaining energy we discard from our human body. Now, for sustainable agriculture, what should happen to maintain the soil fertility? Whatever nutrient has been taken from here, cyclically it should go back. So this is the best way. This is circular way is the best way for maintaining that. But the important thing is, because the human body discard, it has pathogen, because our human gut has lot of pathogen. So if that can be taken here and the waste can be brought back to the villages, this will be a very good source of nutrient back to this. Why I am saying that? Because whatever this organic carbon human body discards, it has lot of organic carbon and NPK. NPK, I think you can immediately comes to our mind is the fertilizer part. So it is rich in organic carbon, NPK is there, so it's a good manure, but because it has pathogenic microorganisms, if that can be taken care, it can be a good manure for us. So from city, the manure can go back to villages, so that is a circular way of maintaining the nutrient of the soil. Why it happens, again I told you, the radiation in presence of water damages the DNA, and that is how the pathogens are taken care. We have put two plants based on this technology. What is the sewage sludge is taken, it is hydrogenized, means irradiated, and then plant growth promoting bacteria are spread onto that, and what we get is hydrogen and this sludge, which can be again sent back to our farms or village areas, which can be again for the nutrition of the soil. Based on these two plants, one is at Ahmedabad and other is at Indore. So this was one thing I wanted to tell you about the urban waste management using radiation. Now let me go to the applications of some isotopes. Isotopes in industry have many applications. This I have shown here in this picture. I will not read out there. Just I'll let you, probably if I show you further picture, you will appreciate it more. See, suppose there is a crude oil line here. Over a period of time, there will be a deposition in that, isn't it? So how to find out? These lines are kilometers and kilometers long. So the easier thing is, you take a thing. See, this is a pipeline instrumentation gauge. This is some, so you can say something which can move with the oil inside this line. So if I put some isotope on that, suitable isotope of course, and then allow it to go there. So if it goes and flows easily, and I put detector on outside from that oil pipeline, outside I am trying to detect the radiation. So when it goes and it stops here, what will happen? Here further it will not go, so I will get the radiation PPA. I will see that lot of radiation coming in. So I will get an idea that there is some blockage here. So instead of opening whole pipeline, one can go to the blockage area, open it. Like this is an example. My colleagues did for one refinery where it supplies oil to the refinery to the airport, and they could find out that at this point, because of this using this radioisotope and this technology, they could find out that there is a blockage here, and then it was removed by usual methods by cutting that part. So you can see how much time and energy it has saved. It was possible because the isotopes were used here for this application. Another important thing is, suppose in an industry there is a reactant, the two things are mixing here, and there is a coolant running outside to cool the things. The coolant is going from this here and coming out from there. Now suppose after some time there is a failure, there is a mixing of coolant and the reactant mixture here, so there is soul in red. Now what happens now, this mixing is happening because of that the desired quality of the product is not coming out. How to find out? Very easy. If I inject an isotope into this, and if I monitor the coolant, I will see some radiation in this coolant. So there should be a fair indication that there's a failure of this wall of the reactant. So easy, you can see that just monitoring the isotope and the isotope can be noticed at very trace level even. So how easy it is using radioisotope to detect the failure in this type of system. Now I give you an example. Actually, the coolants in industry levels are so huge. I intentionally showed this diagram. If a person of about 5.5 feet is like this, the coolant channels are so huge. So our colleagues have done many experiments in many areas in India, in many refineries, and these things could be done only because the isotopes were used for this detection. Another important thing is water resource management. I think most of us think that there is what radiation has to do with water resource management. I'll give an example here. See, there are many applications of this. I will not read it out because of paucity of time. Let me give an example. There's again many listed here where the water. I'll give you this example. Now remember, hydrogen has 3 isotopes. 1H, 2H, 3H, hydrogen, deuterium, tritium. Similarly, oxygen has O16, O17, O18. So you can see many isotopes come before. Now remember, tritium in hydrogen is 1 in 10 raised to power 18. So and tritium is radioisotope. This has a half-life of 12.3 years and the beta emitting. So even in 10 raised to power 118, if there is one tritium, it can be monitored because it is isotope which is giving more radiation. Now for this, these are the mass spectrometer and other techniques, instruments. If you are not simple by any simple analytical done, you want MS for that. Now how it is useful? How monitoring tritium or deuterium in simple water can be useful in water resource management. Suppose I have a hill here. It has 3 tips, and I have water. This is H2O or H2O, D2O, and T2O. I told you hydrogen is atomic mass 1, deuterium is atomic mass 2, tritium is atomic mass 3. Now over a period of time, because of the atmosphere temperature, you can see the lightest isotope will go up to the top, the next heaviest will be then, and the heaviest will not go so high, it will be. Now suppose precipitation after rainy season, these all 3 come out. So whatever has this red isotope will come and sit in this valley, similarly the blue will come and sit in this valley, similarly the red one, the heaviest one, will come and sit in this valley. Now suppose this all water comes down in this part, all it is coming down. Now if I measure the isotopes in this sky blue color I have shown, now you can see I can find out whether this is tritium rich or whether it is deuterium rich or H rich by using mass spectrometer. From this I will be able to come out if this water is coming from first valley, second valley or third valley. Accordingly, we can put check dams on that height so that we can check them at proper height and no need of putting check dams over all that. So I think you can appreciate here that by using isotope, how easy it is to find out where the appropriate check dams are. So these works have been the implementation, this knowledge gain implementation to Uttarakhand and many places to form contours and dike ponds where the water recharge has happened as shown in the bottom right picture. These are my colleagues who have gone for experiment there. From the last example here, you can see I think you may be aware that the crude oil, there are many fractions, diesel, petrol, aviation oil. Now this is done, the oil is heated and different fraction depending on boiling point sit in different trays. Now suppose some trays followed on what to do. Now there is very easy way of doing it. You put a source here and detector here and run them parallelly across the floor. Now this is 80 meters long. If you see wherever there will be attenuation means when radiation जहाँ रुक जाएगा, detectors को देख नहीं पाएगा. So you can see यहाँ पर peak height कम हो जाएगा. So externally you can see from top to bottom if I scan this medium, I am able to tell where their track, the tray is not at. This was possible because the isotopes were used for finding the cause of this. From the last slide here, diamonds, I think you may be knowing that diamonds carat means 2 milligram. Now when the diamonds are very small pieces of diamonds fall out from that, we lose them anyway. Now if the diamond is irradiated at high energy, that generates color. Like here I have shown you above, you can see they are unirradiated color, here they develop some color. Now these colors develop have again, for jewelry the colored diamonds have some value additions here for this. So again the small part of diamonds can be colored and made for depending on what color one will get, it's not always blue. depending on the impurity and the defect created because of radiation, the current will be generated and it can be used for, again, it's a value addition and it can be used for jewelry. So these are some of the related work which I presented just now. So this work, thanks to all my colleagues. And I like to acknowledge my team at RCIG and other divisions of BRC, DMPD, NPD, our other institute, our university, good university, Sri Ram, Mint Malaysia, MA Myanmar, IA for all their collaborative work, all their support. And just note what the effects are. Radiation isotoxicity is the worst type, as I tried to speak to all of you. Radiation possible materials do not become radioactive. Please note that by irradiation nothing becomes radioactive, otherwise we all, myself, Acharya, know that we living today. So, radiation is an antidote for synthesis process of a wide range of materials, particularly for high purity if you want. And isotope natural, artificial, naturally like lithium, and artificial like for healthcare I told you. Find unique application in the step troubleshooting process that is involved. Thank you for your kind attention. Thank you. I'll be happy to take some questions. I'm there, sir. My pleasure.
Thank you very much for talk. Actually, we are also very much thankful for sending us Acharya here. And actually, in the here, and also we are sincere thanks to allow Dr. Acharya, the head IRKB, and Dr. Badal sir, to come here our university of the remote area, and the schools are pretty much being listening to all. And I think in the future we will invite you to come here and also directly to talk our students and our people are interested to meet you in person.
Yeah, sure. If I get an opportunity, I like to be there, Professor Nanda. So sorry for not being there this time. Profusely sorry for.
Now I request my faculty friends and the students to ask the questions to sir.
Yeah, it will be my pleasure. Good morning, how are you? Yeah, tell me. Yeah. Yeah.
Electron beam transmitting technology, does it can be used in electromagnetic radiation like metal beams?
See, there are two applications. I think I am audible. You can hear me, no? Yes. You can hear me. Okay. I tell you, see, there are two type of applications. Here in where electron beam irradiation, we intensely want irradiation to initiate a chemistry. We want to bring out a chemical change in the matrix, isn't it? So here, my intention is to generate radicals and ions in the medium. In the electromagnetic, whatever you are telling, there you are using the interaction of magnetic field. This is only just what you are trying to do is, we try to interact magnetic field generated and magnetic means available, so that there is no friction. It's a difference of few between these two. So there is no chemical change as such. It is only a magnetic field interaction between the two tracks, the things which is moving and the thing which is static. So here electron beam is being used to make out a chemical change, where the other case, the levitation, this is only just an interaction to keep the things moving, and there is no chemical change in that. So these are that way, they are two are quite different.
They are used for making wires or?
Yeah. No, they are not made to make wires. these are used to irrigate cross-link wires. Cross-linking का मतलब मैंने बताया, see दो चेन आप ले लिया, सबको धागा ले लिया 2 पीस, उसको अब देखो धागा अलग अलग रहेगा ना, उसको निकालना आसान है, पर यदि वो उलझ जाएगा, उसमें गांठ पड़ जाएगा तो निकलना मुश्किल है। हम मैगी खाते हैं ना, मैगी देखो एक तार, उसका एक धागा निकालने की कोशिश करेगा तो फोर्स लगाना पड़ता है। सो जितना उसको उलझा लेगा उतना उसका स्ट्रेंथ बढ़ जाएगा। इस प्रॉपर्टी को हम यूज करके इरेडिएशन से उसको क्रॉसलिंक करता है और उसका स्ट्रेंथ बढ़ाने का कोशिश करता है। दैट इज द एम हियर। वी डोंट मेक ओनली क्रॉसलिंक द केबल्स। आई थिंक आई हैव आंसर्ड योर क्वेश्चन।
Thank you, Nikita ma'am, for your question. Next other. Others,
क्या सामने सामने
सामने आ जाए.
Good morning, very good morning. How are you?
Assistant professor in business department. In your post
Oh.
curriculum, for the first time in university curriculum, we have introduced to our radiation biology as a chapter. वो उसमें लिखा गया है वो संसार जितने भी रेडिएशन हो रहा है, माइनिंग की वजह से कैसे रेडिएशन हो रहा है, थोड़ा यहाँ का जो ऑक्साइड माइनिंग हो रहा है ट्रांसपोजन, उसका सारे डेटा ज़्यादा से ज़्यादा सब आपके कोलाम में मिलते हैं, कोला पैन। कोलाम से क्या होता है, उसमें हाइड्रोजन से पावर मिलती है, उसके बाद में हमारा इरिगेशन सिस्टम को सारे जाते हैं।
शॉर्ट क्वेश्चन
कैसे बता पाएंगे स्टूडेंट को रेडिएशन कैसे इरिगेशन सिस्टम से जा रहा है?
Thank you, Professor Das. It's a pleasure to know that your department is starting some courses on radiation biology. First thing is, I am not a competent person, I am not a biologist, so I don't know. But what I can always tell you that, now suppose there is a query that there is a, there is a mining going on, say 10 kilometers above the dam, your dam. And whether that water which is coming in the dam, whether it is the where from where the mining has happened. I will like to share with you that our paper for hydrology, they will be able to determine whether the water is the rainwater or it is coming from the mining area. Another important thing is whether you said this radiation is coming from there or not. Again, I will tell you. The radiation part. See, जो radiation है वो तो human beings नहीं बनाता, वो तो already land में है. So land किसी भी ore में already radiation is there. Only thing is means whenever there is some drilling or oring, mineral is being removed, it may wash out. But then our department is very particular, very stringent rules are there. We take care that the nearby vegetation, general public and all those things are not affected at all. I don't know whether whatever part you are telling, whether it has been brought to the notice of atomic energy or not. Probably I think that should not be the reason. If there is, our department can be approached and we can do a systematic study of that part. I hope I have answered your question. Thank you so much.
Please be online.
Please be online.
Yeah. My pleasure.
Thank you, Dr. Y.K. Bharadwaj sir, for your insightful session.
Can I see you on screen, please? Thank you, ma'am. Thank you.
Thank you, sir. Thank you, Dr. Y.K. Bharadwaj sir, for your insightful session on societal and industrial application of radioisotopes and radiation. Now we are going to present a token of love to Dr. Y.K. Bharadwaj sir. And I request Dr. V.D.U. sir to present a token of love to Dr. R. Acharya sir on behalf of Dr. Y.K. Bharadwaj sir.
Thank you. Thank you. Thank you. Thank you.
Sir, I am taking on paper with you.
Yeah, my pleasure. Yeah, please.
Tonight I am sitting tomorrow to deliver.
Thank you, bro. Thank you all. Thank you.
So please accept it. Please accept it.
So please accept it.
Please accept it,
Sir,
sir.
please accept it, sir.
Yeah, thank you. My pleasure. Thank you for all this. Thank you, Professor. Thank you. it there. Thank you so much. Thank you. I think I can go offline now. Isn't it? Thank you.
ଜୁନିୟର ପିଲାମାନେ ଆଉ ଟିକେ ଆଗକୁ ପଳେଇ ଆସୁନ, ଆଗକୁ ପଳେଇ ଆସ, ଏଇ
ମଝି ପଳେଇ ଆସ,
ପାଖକୁ ଆସ, ପାଖକୁ ଆସ,
ମଝି ପଳେଇ ଆସ।
ସମସ୍ତେ ମଝିକୁ ପଳେଇ ଆସ। ଯେଉଁମାନେ ଟଏଲେଟକୁ ଫେରି ନାହାନ୍ତି ତାଙ୍କୁ ଟିକେ ଡାକି ଦିଅ, କ'ଣ କରୁଛୁ ସେଠି। ପିଲାମାନେ ତମେ ଆଗକୁ ପଳେଇ ଆସ।
ଏପଟେ ପଳେଇ ଆସିବେ ଭିତରୁ ପଇସା ସେ ପଛରୁ ନାହିଁ ଆଗକୁ ଟିକେ ପଳେଇ ଆସ, ଆଗକୁ ପଳେଇ ଆସ, এই সেই সাইডে পড়ে যাও, কম লাস্ট লাইন ଟିକେ ପଛରେ ଦେଖିବେ
ସାର୍
WhatsApp ପଛରେ ଦେଖିବେ।
ସାର୍ बसून सर आगे सर
Now I invite our session chair Dr. B.B. Nanda sir and co-chair Sri Gyanaranjan Mohanty sir. I feel honored to introduce our next speaker, Dr. Raghunath Acharya sir, head of IRAD, BARC Mumbai, to take the stage and grace us with his knowledge on introduction to nuclear science and material characterization using radio analytical techniques. Dr. Raghunath Acharya sir is currently heading Nuclear Analytical and Accelerator Chemistry of Radiochemistry Division, Bhabha Atomic Research Center, Mumbai. Dr. Raghunath Acharya sir is a professor in chemistry, Homi Bhabha National Institute, HPNI, TAE, and head of Isotope and Radiation Application Division, Radiochemistry and Isotope Group, BARC, DAE, Trombay, Mumbai, 40085. In 1992, MSc Chemistry, Ravensa Autonomous College, now University, he obtained his first class first position. In 37th batch Chemistry, he joined his BARC training school in 1993. He obtained his PhD in Chemistry of University of Mumbai in 2000. He obtained his postdoctoral fellowship at Dalhousie University, Canada from 2000 to 2002. He had interest in areas of research work, mainly nuclear analytical chemistry, and chemical characterization of materials R&D work using neutron activation analysis NAA, promote gamma ray NAA, PGNAA and ion beam analysis PIGE and PIXE utilizing research reactors and particle accelerators respectively, and application for non-destructive analysis of samples belonging to various fields, CQC of advanced materials including glass, ceramics, alloy oxides, carbides, relevant for material sciences and nuclear technology. Societal application of isotope hydrology, groundwater resource management and industrial application of radiopressors mainly introduced by nuclear research reactors. His publications are international journals, more than 190, conference more than 300, ITS more than 100. He is a recipient of IANCAS of Dr. Tarun Datta Memorial Award 2003, Young Scientist Award 2008, YSA 2008 and Scientific and Technical Excellence Award of the DAE for the year 2009. He is an elected member of KZNO International Scientific Committee and is presently working as a task force member of BARC for utilization of BARC facilities like research reactors and particle accelerators by university faculties and students through UGC, DAE, CSR collaborative project scheme. I heartily welcome Dr. Raghunath Acharya sir to deliver his talk.
Okay, good morning. Am I audible? Accelerator. Yes, what? Yes, I got it.
धीरे धीरे आराम से
Very good morning. Thank you, the University Committee, for your guest faculties and VC to organize this meeting. And this will be our interest and your interest. It's not one-sided. So I may today morning I just talked to junior college students. Introduction to nuclear science. I hope you will have a little more understanding than what the junior college students know. Okay? So I will give you some basics of nuclear science. Then exactly I will go to my topic what I have told, material characterization. How to characterize a material, not physical, it is chemical characterization. Okay? And my address details are here. I can be approached through email is better. I hope I will be on there for career, for internship, for PhD, some advice, projects, visits. There is another term after T, there is career opportunity for faculties and students. Every 30 minutes, it will be about 45 minutes. India got its independence in 1947 and 1948 we started atomic energy establishment by Baba. We started first Tata Institute of Fundamental Research, that is for basic research in physics, nuclear physics. But later, in 1954, Department of Atomic Energy started. At the same time, that time atomic energy establishment Trombe started. Kolava, it is DIFR, Trombe is DISR. After Baba's death, 1966, about 70 thermal plants in there and then every Baba Atomic Center. But it started in 1954. The main mandate was study. You know, he's the founder, because Founders Day of 430. He is a great physicist and also he has worked on engineering topics also. The main mandate was how to get electricity, nuclear power, how to enhance the application of atomic energy like uranium, thorium, to get energy. 1939 you were knowing nuclear fission started, 1932 neutron discovery. From that we got a lot of neutron, lot of energy. Heat energy will do that water vapor, from that you can get electricity from the turbine and other things. But from the neutron, coming from nuclear fission, it will be done for activation or radioisotope, nuclear fission, training and discharge. From that concept, we started nuclear research reactor, nuclear power reactor. Today we have got about 23 power reactors in India and we have got about 4 research reactors in India. The mandate that time set was this. Till today it is very effective. और उसमें एक चीज है, promote broad system to support atomic program, contribute to energy and national security. So what we are doing? Nuclear power, energy, nuclear radioisotope, healthcare, agriculture, food, clean water, national security. Like I don't tell that you have submarines where reactor is giving power to all the submarines. So lighter way, nuclear battery, it can go to satellites, it can go to Chandrayaan mission that gives nuclear battery by either alpha or beta decay, you get a battery which is load of charge. As long as hard work is there, it will go on giving charging and get a battery. So now we are thinking a battery, like lithium battery, we are thinking nuclear battery, if it is used in the works, it will never decay, one-time battery. So those things are physics and applied. So that's why I wrote that science and societal application of nuclear science through radioisotopes. Our organization is this Atomic Energy Commission, a very big organization in India. Under that there is a DAE, it is under Prime Minister. ISRO, DAE, DRDO under Prime Minister, PMO. And we have Research Council, our prime organization PARC, the father, mother, whatever you tell, the main organization where we work. Then subsequent, we have multiple IGCR, CAD Indore, Calcutta there is DCC, Atomic Mineral, Nuclear Power, IIT, Uranium, Electronics, Bharatiya, Heteroatomic Complex, British supply the radioisotope. We have purchased, we have education institute like PIM, Tata Memorial. All these Tata Memorial Center hospitals are DAE funded. It's a Tata Trust and DAE. They are DAE employee, our employee. Okay? All we are now, Odisha will get a Niger campus is going to get a DLH, Tata Memorial Center. With BNCT, therapy is coming at Bhubaneswar. So a lot of students can join as a PG diploma or DRP, DRA You just go to the website of Niger, IoT, DRC, Data Memorial, RMC, Radiation Medicine. Go to the website of DAE, Department of Energy, DAE, GOV.in, government, DRC, GOV.in. Every information you get. Unless you try, unless you apply, you will not get. No one will come and take it. So we are giving the idea to try, and the sky is the limit. There is no limit. So you can get it. Okay? This is a view of ERC, bird's eye view, very to sky, and come to somebody was asking why sky is blue, because scattering of blue light is more. And why the sea water is also blue, deep to sea water. Anybody can answer? Physics person. Sky is blue, scattering of blue light is more. Why the deep sea water is so blue? So, anybody? Physics. What is Raman effect? See the Raman effect? Who got Nobel Prize? Inelastic scattering of light. Which is rare scattering. Inelastic scattering. What is elastic scattering? Sky is blue. Elastic scattering energy doesn't change. Inelastic, there is a rare phenomenon that is that deep sea water is blue. So they are both light. When Raman discovered it, so he knows that he will be getting Nobel Prize. At that time there is no flight. So he started visiting before the Nobel Prize was announced. So here he would reach in 10-15 days. उसका travel start हो गया था because he was going to get the Nobel Prize. Well, senior Nobel from our South India. He was in ISA Bangalore also afterwards. That's the thing. Now you can ask why no Indian scientists are getting Nobel Prize. So maybe our research is not that great, or we don't get that much support from international. It is YouTube. Somebody will be listening. This is RNLC, Elephanta Cave, University of Mumbai. What was happening in this road? What was happening is not nuclear science, that is a civil engineering. That the largest, longest dam or road or bridge over the sea. 17.5 kilometers is on the sea, 5 kilometers the 22.5 kilometers, that's what I was saying. Okay, here. Here you can see Cyrus Druva, Bordeaux laboratory, one of the longest laboratory of Asia, in one campus. Then he has 11 halls, and city building. This is our campus. We have laboratory here, we have laboratory here, and my laboratory is focusing here and somewhere here. 1956 we started research there at Apsara, name is Apsara. 1966 Canadian collaboration, UK collaboration. आप सोचिए 1954 BSc started. In 2 years we got a research reactor. How great is that time? 1960 Canadian collaboration Cyrus reactor research reactor. Research reactor main purpose is research, radioisotope production, nuclear research like nuclear activation, nuclear scattering, and training. You might be having here in Tiger reactor, TRIGA. Training, research, isotope production. G is a company. Training, research, isotope production, private reactor. That is way we have research reactor. 1985 Druva. I will show you some in my career profile inside Druva. Not now. This is the fully indigenous, fully India. Our research reactor. This is the highest power research reactor in the world. 100 megawatt. Like that way. You have to praise your country. Then you will be very happy. And this recently, Apsara reactor is old, so new Apsara has come upgraded. And this light is blue green for 7 radiation. This is the campus from the ARC. This is our view, the hill. This is Cyrus, this is the garden, this is the admin building, this is our auditorium. This is our computer, supercomputer facility. This is Colaba TI for Tata Supercomputer Research. We have some links, you can take photo. You can go to PAE, we are research funding, your funding for research funding, for collaboration, for conference, Rotary conference, you can ask for that, you can get. We have anchors, you have seen, but main body is in Bombay. We have brief for radioisotope, now home delivery, radioisotope can come to your laboratory. Like courier comes, radioisotope can come to your laboratory. In the flight, and they will come and give you. But you have to pay money. The idea is here, and all unit, uranium compressor, atomic mineral, nuclear power, nuclear fuel, heavy water board, nuclear physics, variable energy, and scientific physics. And numerous groups. How radioactivity, how nuclear fission, how reactor started. In one slide I am giving. This is my self-made slide, not copy paste. 1895 the Roentgen X-ray, that is from atomic phenomena, eruptor. But radioactivity is 1896 a factorial. There was a double shot of uranium in a dryer. Luckily there was a zinc sulfide screen. And Becquerel found the zinc sulfide is blackened, black again. He found something is wrong. Then he found double shot gas, potassium uranium sulfate. But he could not determine radioactivity. After 1896, in 1903, Madam Curie Perry, both husband and wife, who discovered radium and protactinium, Pa, from this lake. She told the term radioactivity. दूसरा बोलते हैं सत्याग्रह पूजा करके नामकरण करेंगे. They give the term radioactivity. Now discovery was by Becquerel, and name current and research by Perry Curie and Marie Curie. So when Nobel Prize was announced, what to do? Because main person Becquerel, but he could not name it. He told something is there. Something is happening. Ionizing radiation is there, something like that. The Nobel committee decided who will give prize to three. How to decide? Husband wife is there. So उसको 50% दिया गया. 50% went to Becquerel. So you can clap it. This is called award distribution. Clap it, right? All three got. But it is a good justice. Many people are trying. I did my work, but my award got taken as summary. अभी 11 फुटबॉल खेलते हैं. गोल जो मारता है उसको मिलता है मैन ऑफ द मैच. बट एक्चुअली गोल जो मारा, गोलकीपर से 10 प्लेयर्स को हेल्प किया. बट फाइनली अवार्ड मिलता है जो गोल मार दिया. लड़के पकड़ा जाएगा, ऐसे मारा जाएगा, तो फाइट ले लेंगे, तो सब हो जाएगा. It is the 11 players not playing. Always think united we stand, divided we fall. So that's why the Garland next year खेलेगा नहीं, कोई छुट्टी करेगा, but the fair India is losing now all matches. So this is my view. When team is working, team should work. मैं maximum time तक 1 hero बन जाएंगे, नाता सर नहीं बनेगा. So नाता सर please see that team should be recognized. So that any program, any work, any research, any education, it is a team. There are persons like HOD chemistry, he doesn't speak more, he may be talking more. Some people are speaking more, talking less. We need all combination. That is the answer. So united we stand, united we please be a teamwork. That is from Nobel Committee decided like that way. So radioactivity is nothing but alpha. It is nuclear phenomena. It is X-ray, is atomic. यहाँ से शुरू हुआ nucleus. 1932 there was only alpha radium. Radium by Marie Curie. So alpha in reaction, alpha beryllium 9 we got neutron by Charlie. Because of neutron, today neutron activation product, radiation and neutron fission product. So no neutron, no activation, no neutron, no fission, no neutron, no DE. We thank neutron discovered today our atomic energy and society. So this is that the alpha ray is going to the gold foil, lot of scattering. Out of 800, or 760. So, like one out of 800 or 760, one is returning. Maximum other is going. This is James Survey's claim. So this famous experiment called scattering experiment goes there. Atom as a full is empty. Most of alpha passing through. There is a positive charge, because alpha is positive, helium. Positive charge centered inside the atom, that is returned to alpha. That is a smaller and larger scattering. So that was termed as nucleus. So the nucleus, we have proton neutron, hydrogen has only proton, all atoms are proton neutron, and extra nucleus is called electron. We have 108, next slide, we have total 108 elements, no research going on. We have 275 stable isotopes, not decaying, and many are beta minus, many are beta plus, red, and many are alpha. Some isotopes are stable, they do not decay, they are stable isotope. Those isotopes having higher neutron than proton, neutron is that is beta minus, like 460, 199, iron 131. Fluorine 18 PET, sodium 22, they are positive emitter, let's start. So you know what is isotope? Isotope, same shape, same mass, same neutron number is isotope. A, Z, N same, energy different, therefore isotope. Examples are there. Very simple example I have given isotope. Argon 38, potassium 39, 18, 19. So 20 neutrons. So the same neutrons isotope. Same mass isobar, like your friend said, same mass, 60 kg, therefore isobars. Okay, like that. Like hydrogen, 1, 2, 3. Protium, deuterium, tritium, they are all isotopes, but 3 different masses. So what you see, there are a lot of protons, lot of neutrons inside the mass. But nucleus, you think, if you think of it, please focus. Backside में बात मत कर रही है. Hello. Think of a cricket field. If the cricket field is the atom, the boundary, the ball is the nucleus. or male. Actually, I call it ball. Ball देखिए कितना छोटा है. So atom बहुत बड़ा है. So atom is 10.5 times larger than the nucleus. And all masses, proton neutrons are inside the nucleus. When you go on increasing the jet, you are increasing neutron. All masses are inside a small area, 10 to the minus 12 centimeter. Very, very small. It's got a high nuclear density, like 10 to the power 14 gram per cm cube. Can you imagine in a cm cube so much mass can stay? Take about 13 nucleons, proton neutron. I can imagine. So such a large mass, how to stay? That's force called nuclear force. It's very strong, it's very attractive. It's short range. Within the radius, बाहर जाएगा तो फिर otherwise wall will collapse. It is within the radius. After the radius, it is zero. Then binding energy, other things are there. Mass defect, you know, total mass, neutron total mass into the Newton total individual mass is positive. The mass loss is converted to energy delta F square is equal to Einstein's law. Okay? If you go on increasing like proton nuclear dt, it is called fusion. Mass is increasing, binding energy is increasing. If you do nuclear fission product is coming here, binding energy is increasing. Whether you are nuclear fusion or nuclear fission, dividing, your binding energy for nuclear is increasing. It's both the nuclear fusion and nuclear fission are energetic and visible process. That's why it is occurring. Can you imagine fusion, energy increasing, fission, larger mass coming to smaller mass? And if you see uranium fission, you calculate that in one uranium fission, I get a gain energy 200 megaelectron. This one energy fission of uranium, I get 200 megaelectron. If you take 1 gram, it's too much energy. Okay? Here I have already told. Here already you know what is alpha decay, what is beta minus cell isomer, beta plus is जैसे कि chlorinating, ये Z minus 1, and if you do isolate transition, it is Z acid, it is only the energy difference, that is iso 1. If you want see old symbol like a fan, the new symbol is the radioisotope in a container or a car, then they give a symbol like this. Radiation is coming, like mainly gamma. It is dangerous, like your electrical frequency. You can hear, no? This with the idea. ये आवरे, then middle level में कोई नहीं रहेगा, सब लोग उड़ेंगे. Please don't be nearby if there is a radiation. अपना काम करो, okay? It is not a like love or it is not a proof to be nearby, okay? Alpha beta gamma, alpha is positive, beta is negative, and gamma is no charge. And this is the story I told. The radiation to identify is applied by the energy that will characterize. In decays, when there is a number of atoms, radioisotopes come to half instead of half pi. So TR. TR can be in second or year. This is the decay. 40,000, 4,000, 2,000, it is called TR. So it is about 15 minutes, 15 days. TR, you can easily plot activity versus time. Naturally, we have a lot of radioactivity, like this house also. The wall who are nearby, you are getting no radiation. The person who is inside the room. If you are getting from the bottom, you are getting from the side. Because any soil, any brick, any rock, everything has uranium thorium naturally. So they give always some radiation. The house which is closed door, window, like kids are studying always with the closed door and window, they are getting more radio activity naturally than the person who has opening the door and window having ventilation. If you see your old house in village, there is a through and through, like front and back, through and through air circulation. So they are better living. हम बोलते हैं ना गांव में अच्छा खाना है, अच्छा लिविंग है, और गांव का पर्सन अलग है, उनका बस और कुछ कास्ट नहीं नहीं, but you get relaxed. Suppose you are medicated every day, you go village, you forget I have not taken medicine, but I am okay. Because you get relaxed life, not because you are very young, overall you get relaxed. Okay? हवा पानी खाना सब अच्छा लगता है, but if you still want to then again फिर खाना पानी में डाउन जा रहा. Anyway, the science is air ventilation should be there. If the fresh air comes, radon is a particle in the air. If you close the door, other things. That's why in Japan like country they make close the wood or plastics, so that radiation due to natural radiation is very less. That is the science. We do not go for that is science, so that you naturally you should not get radiation. How to get radiation? Your medical X-ray, CT scan. They already you can avoid. With height, मेरा CT scan पहले करो. But you do not know that each CT scan is giving 50 to 70 times of X-ray scan. अब अच्छा X-ray हो रहा है, जितना है CT scan is whole body. तो जितना बन रहा है, it is higher dose you get. But with height there, मेरा CT scan पहले करो. You do not know that you are getting dose. So curie, becquerel, one nucleus is one curie, one curie is 3.7 10 to the 10 nucleus. So becquerel का नाम में unit आ गया. Specific activity is activity for mass. How to detect? We have got multiples. We have healthy persons like yesterday, Dr. Parker told the drug, so they can measure and tell, that's the advisable. We have B-mode who are like negative pressure who are. A chemical B-mode and radioactive B-mode different. We are having always negative pressure, all the thing one tube, out to in, out. Locus or alpha is a closed container having one. Put your hand at one, alpha will not come to the nodes, you are one. Hot cell is high radioactivity, 160 is going through India for gamma, cancer cure, food radiation processing, slug hydration, all the cobalt 60 is coming from power radiation reactor from India. It is a hot cell having laid one. People work from outside. They do all processing, how they work. But there are ways, we are scientists, you know how to protect. Alpha can be stored with a piece of paper, your sack or cover, gloves. Beta can be stored with a piece of aluminum. I think yesterday Professor might have told this. And gamma can be stored with lead. Higher the lead, higher the automated atmosphere, it can stop. So it is the time we start shielding. Plan to work less, means be near to radiation of less time, keep a distance, and maintain the shielding. I am shielding of a control. (1932) neutron and 1939 fission. Fission is like that way. They were taking uranium with the neutron to get neptunium. But by chance, neptunium produced the fission आ गया. They got barium and krypton. So then decided that the neptunium चाहता है क्या हो गया? Means uranium खुद break हो गया. That's called fission. That is why Otto Hahn Strassmann, both are chemists, they discovered nuclear fission. Physics theory, mathematics, physics. So I am justifying physics and chemistry. You get products, you get energy, heat energy, you get neutron. Our aim is this of helpful, this is helpful. From neutron we do fission, activation. This energy will be used for nuclear power reactor, this is heat energy, water vapor, turbine, and you can get electricity. You can make many fission products. They are very helpful. Molybdenum, cesium, iodine. They are medically important. This is a reactor. Now nuclear fission हो गया, then there is a reactor. In nuclear reactor we have fission. You get fission products. You get neutron. The controlled chain reaction is called criticality. This is the that's a video not working. So here is the fuel uranium, nuclear fission, the heat energy, the water is getting heated, transport, then it is running the turbine, then generator, then electricity. Same water is getting cooled, again coming back. That's why all research reactor power reactors are near to a sea, so that we can take water for circulation and cooling. Not that it was said, it is the water requirement for cooling. Last research reactor 1956, second is Cyrus, and 60, revised in 1985, first test reactor Kolkata in 1985. Gamma in 1996, 2018 is also an upgraded now. They are research reactor, power is there, mainly for isotope production, nuclear physics experiment, neutron activation, neutron scattering, neutron diffraction. We have Apsara building, we have Kamini, might have seen the TV Cyrus Dhruva. This is the highest power research reactor Dhruva of India. This is FBTR Kolkata. So we using this neutron, we get a neutron activation product that is called radioisotope. Like you take tellurium, you get iodine. You take molybdenum, you get 99. From here you technique you get that is for imaging of tumor or cancer. we have got accelerators throughout India. We have got, I don't know how the thing is coming. Here is KF, Calcutta, Bhubaneswar, Kolkata, Hyderabad. Here is the accelerator to Bombay, India. Here is cyclotron. This is fluorine 18 from cyclotron with a PET scan, PET, polymer photography. How is Dr. David? Okay. Here is the radioisotope for healthcare, for industry, for research, for agriculture and food. In radioisotope, we have learned three things. Diagnosis, whether that is not always tumor cancer. A normal body can scan whether I have any tumor, whether it is carcinogenic or not. It's not always a cancer person has to be treated. Even radioisotopes are helping for the like heart, what you can tell, blood flow, that heart functioning, failure. Iodine 131 is being used for vital thyroid functioning. Fluorine 18 is helpful for PET scan, vaginal X-ray tomography. Nowadays, as to detect if there is any tumor cancer, then you surgery it. Again, there is a radiation or gamma or electron to stop the growth of cells. It is everywhere in India now, including Odisha, Bhubaneswar also. This is a kit we send recently to different laboratories for testing. This is the scan, body scan we get, photograph. This is the body, it goes, human goes there. You then scanning is there, detector is there. Either sonograph or HPG detector. Here is the scan, just showing the blood body, is a photo of it. This is fluorinating with glucose, 1 minute. It goes the body, after 2-3 hours or 4 hours, there is no radioactivity inside the body. Or 5-6 hours. These aspects are helping for the diagnosis, like iodine, technetium, thallium. This is for tumor and heart. These are the treatment. Iodine can treat your like thyroid or vital things. Chemical nuclear medicine. So you can see how thyroid growth is there. Father of nuclear medicine, even father of nuclear activation is Judge Henderson. Nuclear activation I work. Judge Henderson is the father of nuclear medicine. He started radioisotope as a diagnosis. He got Nobel Prize because of his nuclear medicine or nuclear activation. He is a Hungarian scientist. Yesterday I already shown the balance that how the heat effects are coming. I am not talking much. But what I will tell here, you can get a variety like gamma, which is a different variety than what you are using, mutation. Yield is more and quality is not less, quality is better, and there is no change in nutrients, no change in gene. You can stop sprouting of potato and vanilla by gamma irradiation, bacteria killing. You can send the mangoes from outside country by killing the bacteria, give a certificate quarantine. It can go to abroad, Europe, America, other countries because they fear our fertilizers. India uses a lot of fertilizers. So India should go for bio-fertilizer, compost, like over Pela old is gold. You production बढ़ाओ और national soil खराब. There are industrial applications now. My division is working. Radioisotope, very simple, big pipe, small leak, very difficult. A radioisotope can easily detect. We have products for sterilize, medical products, ointments, syringes, many things. We have radioisotopes for research, physical, chemical, and chemical. And I will start my next part for analysis. So this is one part over. Another part after 15-20 minutes I will talk about characterization. So we will take a 5 minutes break, some question answer, and go to next. थोड़ा क्वेश्चन आंसर करा दीजिए. Some questions. हाय दीजिए. मैं बैठ के आंसर करा था, टायर्ड हो. इंजीनियर कॉलेज में भी कौन स्टूडेंट है इंजीनियर कॉलेज में लेक्चर सुना? प्लीज कोई ना, एक दो स्टूडेंट है इधर. कोई नहीं? नो स्टूडेंट, नो स्टूडेंट हियर. Good.
Hello sir, good morning. Myself Pranav, PhD Secondary Department of Chemistry. My question is that in the nuclear reactor, how the core is functioning or working? In the nuclear reactor, how the core is functioning?
How core is functioning?
Yes.
In the core will take energy. Well, ଯେମିତି ଆମର ଘରେ ଯେମିତି ଆମେ ଯେମିତି ଶୁଣ, ଯେମିତି ଘରେ ଯେମିତି ଆମର ଅଛି କାଠ ଅଛି, ଆଜିକାଲି ଗ୍ୟାସ୍ ଚାଲୁଛନ୍ତି, କାଠ ରଖିଲେ କାଠ ଲକଡ଼ି ପକେଇ ସବୁ ସେଟା ଫୁଏଲ୍ ବନ୍ଦ କରେ. ଇରାନିକ ଫୁଏଲ୍. ନ୍ୟୁଟ୍ରନ୍ ଯେତେବେଳେ ଯାଉଛି ସେତେବେଳେ ନ୍ୟୁକ୍ଲିୟର ଫିସନ୍ କରୁଛି. ନ୍ୟୁକ୍ଲିୟର ଫିସନ୍ ହେଲା ପରେ ଫିସନ୍ ପ୍ରଡକ୍ଟ ଆସୁଛି, ନ୍ୟୁଟ୍ରନ୍ ଆସୁଛି, ଆଉ ହିଟ୍ ଏନର୍ଜି ଆସୁଛି. ସେ ନ୍ୟୁଟ୍ରନ୍ ଯୋଉ ଆସୁଛି ସେଟା ନ୍ୟୁଟ୍ରନ୍ ଆକ୍ଟିଭେସନ୍ ଆମକୁ ହେଲ୍ପ କରୁଛି. ଫିସନ୍ ଆଣ୍ଡ ରେଡିଓଆଇସୋଟୋପ୍. ହିଟ୍ ଏନର୍ଜିଟା ପାୱାର ରିଆକ୍ଟର କ'ଣ ହେଉଛି, ବାଷ୍ପ ହେଉଛି. ସେ ବାଷ୍ପ ହେଲା ପରେ ବାଷ୍ପ ଘୁମଉଛି ଟର୍ବାଇନ୍. ଟର୍ବାଇନ୍ ଘୁମିଲା ପରେ ଜେନେରେଟର ଫର ଇଲେକ୍ଟ୍ରିସିଟି. ସୋ କୋରରେ fuel, clad, coolant, water. It's a difference. Clad is equal to stainless steel. Moderator can be water into ताको cool करके full neutron को control chain. जो neutron आସୁଛି पूरी से neutron जाके फिशन करूଛି. ताको control chain reaction. हरे गोटे neutron देला तीनटा neutron आसिला. तीनटा गोटे neutron फिशन कला. आ गोटे neutron activation कला फिशन कला. Now this is liquid last time. It is a control chain reaction. It's called K factor is equal to 1. That is the role of core. Okay? Thank you.
Thank you sir.
Oriental paper में दिखा हो?
हाँ सर.
Hindi paper में Oriental बोली. तेलुगु बोली. Sorry. क्या तेलुगु करना चाहिए? तेलुगु? नहीं, हिंदी इंग्लिश. मुझे मजा करता. मेरे एंजॉय को तब सॉल्व करने की. क्योंकि सिंपल बात है, लाइट बात. पर तब कोई तो सॉल्व दिया जाए, तब ट्रीट करो. What bring? तो ना बोल.
Sir, no, now she Vikram Raj Panda, UG second year, Department of Mathematics.
Of university.
Vikram Devi University.
You are from?
Department of Mathematics.
वहाँ बोलेगा.
India, Jaipur.
Good.
So, sir, our fundamental forces of nature that we know, किसी ना किसी पैरामीटर ऊपर डिपेंड करछे. मींस ग्रेविटेशनल फोर्स हो ता मास ऊपर डिपेंड करछे. और अलगा किसी फोर्स हो ता चार्ज ऊपर डिपेंड करछे. तो हमको फिजिक्स रे जे पढ़ाई था जनरिक इलेक्ट्रिक रे न्यूक्लियर फोर्स चार्ज ऊपर डिपेंड करू नहीं होते. तो न्यूक्लियर फोर्स ता रे कहाँ ऊपर डिपेंड करछे, कारण आमे
न्यूक्लियर फोर्स मात्र बाइंडिंग एनर्जी. बाइंडिंग एनर्जी के बाइंडिंग होची. जो mass of the house, delta element c square, that is binding energy, that is binding. So हमें तक को nuclear force ये जो पहुँचो, ये इतने proton neutron को proton nucleus पे रखो. direct force. Again, that is within the radius it is there. 10 to the minus 12 centimeter. The power is 0. It is the binding energy, nothing. Binding energy coming from within mass loss. Mass is convert energy, na? Same loss. Nothing great. But it is a very weak force. It's not coulombic, no van der Waals, nothing. Coulombic is a repulsor which is against the nuclear force. But nuclear force is higher than coulombic force. That's why it is binding. Neutron being present inside the nucleus is no charge. Proton is positive charge, that is a repulsive force. But neutron is diluting the repulsive force because no charge. That's why nucleus exists. Inside the nucleus, there is a constant exchange between neutron to proton, proton to neutron with pi meson. That is called meson theory. So that's why there is a lot of exchange phenomena. The moment you see the neutron, next moment is proton. Like that, that's why nucleus is existing. There are a lot of theory, but very good questions. So clap for Krishna Panda. Next question. Follow question पचास जे follow question पचास वो मानव पत्र आर गाड़ी आज करें and no money just पत्र.
Good morning, sir. My name is Astronomic Acharya.
Acharya.
No, sir.
Myself Acharya. You are from my village, no? Huh? Jaipur.
Yes, sir. From Jaipur.
Okay.
क्वेश्चन कौन सा जो रेडियोएक्टिव आइसोटोप हम करो तो स्टोर कैसे करवा और डिस्पोजल कैसे होगा?
Okay. Radioisotopes, what we do? I told you shielding. Mainly lead containers. Lead container has half a thickness, 10 to thickness. Each radiation has a thickness. Beyond that it cannot go. We calculate academic thickness of lead is considered. That is true. While transporting, also we have a certificate by ARB, Atomic Energy Regulatory Board. That is also there. So you can transport. Now question is disposal. If it is short half-life, it is the case, no to dispose. If it is cobalt 60, it is high half-life, 5.27 years. You have to store. So it is basically lead container and allow a collimator to pass. Otherwise, nothing will come out. So what I can tell that, no need to fear. Lot of research going. India is having highest safety record in the world. Number one country of safety record in the world by Atomic Energy Agency. India is number one. Not because I am sitting or we are doing. Our safety record is very, very good. No need to worry. Okay? Thank you. Next. Question पचाना मैंने किसी पूछी ना. मैं वीडियो कुछ नारेला कुछ कहे पचाने की आसी नहीं. पसंद हो ना? Nobody. लेकिन तुम्हें से टाइप में हेल्प करेगा. Einstein and always. I thank those who opposed me. They have supported me. Some people patting you because you were wrongly. But there are persons like critical. Your father, mother, sister, brother. They are very critical. ज़्यादा भाषण कर रहे हो, ज़्यादा बात कर रहे हो, थोड़ा कम बोल रहे हो. They are praising you, but they are controlling you. In reactor we have two systems. One is control rod, one is shut-off rod. We control the reactor. When it is not controlled, there is shut-off rod. So every system should have a control. So science also same thing. Human life also same thing. We should have a control mechanism. But don't shy away for questions. I tell you, up to MSc, I was not asking questions. But MSc, I tried to ask the questions. The teacher praised. Even my teacher called me, Sudhan Tripathi. He called to his room. This is the best question of life you asked me. And this is in Atkins book. In this page, your answer. That's why I asked the question. So you do not know. Yes, sir. सर्वोपरि राधाकृष्णन से तो प्रमुख असले आक्रमण असले पड़े थे. गुड मॉर्निंग सर कहया तो से आकर नमस्कार करते से कहते तो मुझे जानी नहीं तुम भीतर किए थी वो मोड हो गया देखो मेरी सब महात्मा गांधी सब मेरे फेवरेट टीचर भी साइंटिस्ट आकर नमस्कार बोलते तो ताकू जे आला टीचर के सब बेस्ट टीचर सो यू डू नॉट नो इधर जे हमारा थियरी भाई अब्दुल कलाम आई थी तो he gives a very good he was president, he goes to school, he was going to colleges. हम लोग तो यूनिवर्सिटी जाएंगे फैकल्टी सामने बैठे तो नहीं टॉप नहीं देंगे नो फैकल्टी आर नॉट गिव टॉप he was interacting with the students 8 9 10 his last day he was going to Ceylon giving a talk in the room he collapsed after becoming the president and he was the missile scientist and he has done a lot of good work for the director of the country. He is really visionary. That is what he told. मैं जो बोल रहा हूँ सुनिए. Who knows the best brain is in the last bench of the class. Let me explain why. तो फर्स्ट बेंच वाला थोड़ा ज़्यादा कुछ करेगा, लिखेंगे. सेकंड बेंच वाला बात करेगा. थर्ड बेंच व्हाट्सएप देखेगा, सोएगा. लास्ट बेंच तो कुछ नहीं. पर्पस इज टू गो अवे एंड कभी आवाज नहीं आएगा फिर भी उनको 60-70 बस मार्क्स आते हैं तो 60-70 फास्ट पेज हो जाएगा तो 100% हो सकता है तो ही टोल्ड हु नोस द बेस्ट ब्रेन इज द लास्ट पेज मींस लास्ट पेज पर्सन नॉट लिसनिंग प्रॉपर्ली नॉट सीइंग द स्लाइड प्रॉपर्ली नॉट सीइंग द फिगर प्रॉपर्ली फिर भी वो 70 मार्क्स ले आता है तो फास्ट पेज हो जाएगा you may be the best 100 marks. So last bench, remember, try to be the first, second bench. You do better. Okay? Shall I go ahead? Chalo. Okay, I am going to my own research very soon. I am finished. But today is my day. After that also tea. Tea है कि नहीं? Somebody should connect जो तो मल्टी हुआ तो जो सोचते मेरा आज एंकरिंग करना है मैं एंकरिंग पर खड़ा होगा तो माइक कौन देगा पता नहीं आपको चिंता करना है माइक वाला आना चाहिए उसको छोड़ दीजिए लाइक दैट इज कॉल्ड मल्टीटास्किंग ऑल आर द मल्टीटास्किंग लाइक वाटर यू शुड हैव वाटर इज द बेस्ट बिना वाटर में जल बिना जीवन यू शुड हैव and the water will be very cold गला खराब फिर वो खराब हो जाएगा तो बच्चों कैसे देंगे anyway I think apart the jokes so I will give you the best part of my research I take you चलिए बढ़िया इसमें थोड़ा जोकर भी लाते हैं sorry chemical characteristic what is chemical characteristic water is H2O इसमें हाइड्रोजन वाटर है और क्या क्या है कार्बोनेट नाइट्रेट सल्फेट आर्सेनिक यूरेनियम सब कुछ हो सकता है वी मे और मे नॉट डिटेक्ट वाटर इज कमिंग वेयर रेन पूल रिवर इज अटैच्ड विद सॉइल रेन वाटर में क्या होता है एसिड में क्या होता है नाइट्रेट सल्फेट ऑल द थिंग्स कार्बोनेट व्हाट इज पीएच ऑफ tap water anybody can tell chemistry pH of tap water pH हैं 7 मिलेगा 7 is pure water कुछ है आप जो पानी पी रहे हो प्योर वाटर है
7.4
डबल डिस्टिल करके
7.4
कितना होगा बोलिए pH 7 के ऊपर होगा और 7 के नीचे होगा आपका गीता वाला बोलो maybe 6 इतना नीचे you are drinking acid कुछ लोग टैप वाटर पीते हैं ना अभी पूरी डिस्ट्रिक्ट में टैप वाटर है पूरी अनाउंस ऑफ 5 डिस्ट्रिक्ट इन इंडिया that you can drink tap water but I believe it बोलिए कौन बोलेगा अरे इतना वैल्यू नहीं मैडम less than 7 it can be 1 So 6.7, 6.8. Clap for madam. Why? Tank is 6.7, 6.8. Why not a 7?
Sir, maybe the soil contain acidic.
जाएगा क्या? Madam, 6.8 is correct answer. Cap बता, cap. Remove that छोड़ो. पता कर पहले. See what you want. थोड़ा सोचिए. क्या हो सकता है? एयर में क्या क्या है? कार्बन डाइऑक्साइड. कार्बन डाइऑक्साइड में वाटर क्या होता है?
Sir, in test water we are using bleaching powder.
मैडम, give you clue.
Carbonic acid.
Carbon dioxide water mix करिए.
Carbonic acid.
That is slight carbonic acid. That's why it is lower. Acid can be 6.95, but it never be 7. If you double distilled, it can be 7. Okay. So there is no pure factor, sir. So compulsory is composition, but there are trace elements. Some trace it can be having many elements. That's why water is tested. There is going aquafina, aquaguard, distillery. We are believing. A distillery bottle में कोई टैप डाल के पाइप टैप टाइप करने कितना डर लगेगा? You are drinking, no? So better drink your own water. Best is own aquaguard, own water. Best water is distilled water. आप गर्म करके ठंडा कर दीजिए. That is the best water. आपका लाभ में है डबल डिस्टिल. ऊपर जाता है आता है. Best water. पर उसमें एक concept है कि there is a कीड़ा, something it is dying and it is inside. So you need a filter. Best water. आप पढ़िए. Today you read what is the best water. आप पढ़े हाँ. ऐसा वाला क्वेश्चन बनाएंगे लाइफ में. Then you start a startup to supply best water in Korapu. Clearly. थोड़ा पैसा लगेगा लोग आएंगे. Food. Food में क्या होगा? कार्बन, हाइड्रोजन, ऑक्सीजन, नाइट्रोजन, NPK, phosphorus, potassium. Beyond that क्या है? It can be having sodium, potassium, cobalt, zinc, manganese. आपका जो खाना में है, all vitamins we eat, it is in food. So we call it, use food as medicine, not medicine as food. आपका food में सब कुछ है. I can tell everything which food can supply. You do not need a medicine. But I am not a doctor. I am a PhD person. There are many techniques to characterize. There is a spectroscopics, but today I talk about nuclear techniques. Okay. In nuclear, we have neutron, we have charge particle, we have accelerator, we have reactor. अरे पढ़ना जैसे अभी समझ रहे हैं. आज मुझे छोड़ेंगे. Today I have to go Bombay. You are not understanding. You are interested. Very good. So, in activation, chemical activation, energy. If it is ion, we call it particle acceleration. हमारा कैसे accelerate होता है? ऐसा fix ही होता है. There are many techniques in that is called nuclear techniques. It will be applied to geology, biology, nuclear science, forensic, archaeology, chemical science, nuclear technology, healthcare, everywhere it can apply. What is there? We are analyzing. अब सर्टिफिकेट देगा ना. जैसे आप प्लॉट दे रहे हो, प्लॉट का आता है ना रिपोर्ट. Exactly, if you give a product like soil, food, water, alloy, you will salt में iodine, water में arsenic, food में selenium. You know there is a district where many people hair loss हो गया. Your shampoo में selenium. You are using shampoo. You look very handsome or beautiful. But shampoo will take your hair. That shampoo should have less selenium. अभी product आया जो wheat, इसमें high selenium था. डॉक्टर सब बात कर रहा है. high selenium is high toxic. But your कांदा लहसुन उसमें selenium है, low selenium, it is antioxidant. It is very very helpful for you. Same element, lower concentration helpful. Same element, high concentration toxic. Like hyper, iodine. Hyper is super, higher iodine better. Low iodine also deficiency. आपको weakness लगेगा. आपको जो T3, T4, TSH टेस्ट होता है, that is basically hormone and iodine. आपको weakness हो रहा है, you do not know why. You are not able to eat properly, sleep properly. There are issues mainly because of vitamins and some hormones. So you use neutron for neutron oxidation or proton for CPT, and you do many elements, hydrogen, uranium analysis. You take a target, neutron is captured, and a compound nucleus gamma is coming, then you measuring gamma for the analysis. So what are you doing? Gamma ray is coming, there is a detector, you are measuring, and you are analyzing what element, how much is there. Again, same person, 36 Newton activation. Isotope, many elements, not several elements can be done by this technique. We have activity and there are a lot of equations, so don't worry about this. We get flux from reactor, we have a cross section, the area provided by the target, then there is a equation. Higher the flux, higher the sensitivity, higher the cross section, higher the sensitivity. So that I told. So these are the elements you can do below from hydrogen to uranium. There are different detections you can do by neutron activation. There are techniques to calculate. We do take sample, small labs, put in the reactor, bring out, analyze. Sometimes we do direct online. Online you can do. Sample रख direct online यहाँ से put TGNA. This is Apsara. These reactors are used. This facility they are do that. In 1 minute you can analyze the sample. In 10 minutes you can get the result. That is complementary carrier facility. This facility is mainly I am using. This is a gamma spectrum, you can see. Here is calcium, aluminum, sodium, magnesium. Very simple spectrum. Here spectrum can get everything. All ions, hafnium, scandium, lanthanum. In one radiation you can get 15-20 elements very easily. We do lot of accuracy. Since you are not, see how quality will be assured. They are open my claims and they are okay, I am very accurate. I am talking not boldly. Your analysis will tell that I am 100% accurate or 91% accurate. I have 5% error. Okay? You do lot of research. This is my career research. I started my career 1997, my first paper. Like gemstones, noodles, cell, food, sediment, code, code bias, archaeological, many works we have done. But many times we do a small sample, like 100 milligram, 1 milligram. But my research started that I can take a larger size, give a better result. So we started a method, they put publications, like zirconium tin alloy. Here is spectrum, you can see everything, how it is coming. You can get the values, zirconium and other elements. Zirconium 98%, you can get hafnium, indium, you can get less elements. Stainless steel, the highest metal, steel, stainless steel is worldwide, highest metal. But quality, we can do without this standard, I can give you whether it is a good quality or not. Stainless steel, directly without destroying. Since I am in Odisha, we got a request from Nehru Planetarium. In Kedrapada, there was a meteorite fall in 2003. The sample came to me. And reservoir crystal, it is a meteorite, not a rock. It can be rock, no. How? Because the iron concentration was 23%, where rock may iron will be 10 to 12%. Clearly, it is not from Earth, it is from somewhere else. And we named it a Jagannath meteorite. But there may be people told that Jagannath is in the world. There will be Muslim, there will be Christian, there will be others. But ठीक है, ओडिशा के जगन्नाथ है, we named it Jagannath meteorite. Not me, those persons. So our paper is in current science. The paper we published as a Jagannath meteorite. And you can class it. And we told authentic meteorite. That is the way we work. Sample come and work in history, but that gives you a confidence that you are working and your results are very important. Even if one medical sample can be analyzed to give the result. I quickly finish, don't worry. Today it will not, it will be ending soon. 5 minutes. Uranium ore is our interest. Uranium चाहिए तो हमारे पास uranium नहीं है. गरीब है. But we are searching. We do bias. Bias is having high heavy metals. कोल में जो कोल होता है ना, कोल का बाद जो तकलीफ होता है कार्बन डाइऑक्साइड, bias, बहुत तकलीफ है. उसमें आर्सेनिक है, CGM, lanthanum, thorium is a little high. Uranium in our soil is 2 to 3 ppm. We get little high. Thorium is 10 to 12 ppm. We get little high. Concentrated. It's not high. It is concentrated. We can do coal maybe. There are a lot of more going on as arsenic, iodine, mercury, cadmium. They are all toxic. Chemistry student may be knowing. Whether you can detect at low level very accurately. मैं आपको बोला था ना, iodine below 40, iodine below 50 micron per day, it is called iodine disorder, deficiency. Iodine 150 micron per day from food, it is called hyper, it is deficiency. तो आपका salt में अभी iodine is iodine, आप everyday iodine salt खा रहे हैं. Someday maybe world population get a hyper iodine. So कभी-कभी आपका natural salt लीजिए, but natural salt में mineral भी है, तो salt भी है, but iodine salt में वही नहीं. Okay, so showing the level of richness by a pure salt may take you towards disease. This is my perception. Iodine salt पर आ जाएंगे. सर इधर आइए आपको प्रूव करिए. It is possible. So आजकल मार्केट में आपको देखेंगे pink salt, natural salt, there are salt, black salt, even you are using. So please see natural salt not bad. Try to use salt. Arsenic, you can get a peak. देखो arsenic का direct water मिल गया. Arsenic water in West Bengal, Bangladesh is very high problem. They are treated, all water treated to drinking. And its limit is only 10 ppb, 10 nanogram per ml. But all water may be very high. So हमारे mechanism की है that I have done arsenic 3, arsenic 5, arsenic is no toxic. कुछ मेथड है क्या 10 ppb से नीचे करेगा. तो we develop a method neutron activation and membrane. Its detection limit is 3 ppb. It is a very good method. We published a good paper. Iodine very low iodine how to do? I developed a method on that is called epithermal NA, and there is a very good paper. In fact, about 8 or 10. This is one of the PhD. There is another PhD of my student. We got a very good paper on iodine on food and iodine on salt. There is another two theory on selenium. Selenium deficiency, how it is very selenium, high selenium. People talk about arsenic, nobody talks about selenium. अभी selenium ज़्यादा है पेपर में. That we have already worked in 2008, 2009 papers. We have three PhD on this with Punjab. जो जगह में आया उसी जगह का काम हम किए थे. हमारा वर्क था. Selenium, very high selenium in soil. That is called selenium soil. And you see, Mustard is having 670 ppm. Now let us see chemistry. Selenium and sulfur are same chemistry, same group. जहाँ मस्टर्ड प्लांट में मस्टर्ड सल्फर, तो वो मस्टर्ड में ज्यादा सेलेनियम आ गए, तो आपको सेलेनियम रिम्यूनेशन चाहिए, तो मस्टर्ड प्लांट लगाइए. यूजुअली ये सोडिस का जो अच्छा अगर धान को साइड से लगाओ, it can take out selenium. What they do, if there is a dharma or gahamachi, high selenium, they mix with deficient selenium in the mandi and supply. But probably suppose you are mixing directly दे दिया, हो गया काम, you are getting high selenium. So there is a quality control department should be there in the mandi where it is going out. People don't do that. It is now well proven that you need a analysis before eating. We believe that's why we take packet where that the company name is there. Like that way. Number of the name, मैं number of the काम किया था, लेकिन अंदर, the lot of some papers with me. One was aluminum rice. Clear the paper with me. नाम mistake हो गया, but आपका review number है इधर. You are my collaborator. Your work. Then I am doing nowadays accelerator, IIT has accelerator. I am doing Q into B, Q plus 1 to B. Many places where accelerator I have shown. You can do PIXC, PIXC. Like NA, you can get many elements, but sensitivity not very, very high. But there are no other elements I can do, like lithium ion battery, boron, silicon, aluminum. What is the technique? That is another technique I am working. That is the PIG. I can do lithium, boron, boron isotopic, chlorine. So this is a project I can do. You can think of it as a chlorine program. Lithium ion battery, lithium fusion reactor, silicon, sulfur. So our research was, I was telling I will detect with all element analysis. I can do helium. Which element I cannot do? Can anybody tell? 92 elements are there. Which element I cannot do? Two elements are not really predictable. They are man-made. Anybody can tell? Among 92 elements, two elements are not there in nature. Technetium and promethium. Technetium is from molybdenum, man-made. It is not there in nature. Promethium, PM, in the earth is not there. So actually 90 elements present in the soil. So these are fundamentals. Actually we train the teacher, train the trainer. You can do a FTP, I am telling HOD. Start FTP, faculty development program. UGC started, train the trainer. तो ट्रेन करते हैं, उनको भी ट्रेन करिए. Like I should be trained. My knowledge may not be there in everything. To train the trainer, so trainer will train better the students. So start FDP. You can design a course with IIT, DAE, NIGER, IOT, and from nearby institute, and they come and teach the teachers. The teachers get updated. They are getting updated with the which nobody teaches us. But we are not getting updated with science. So please start FDP, give a proposal to DC and department. Every year, give a topic, material characterization, energy sources, environmental science, radiation photochemistry, advanced materials, materials for energy and environment, so materials for health, materials, good water and health, good agriculture and food. एक थीम रखिए and उसी साल उसी को पढ़ाइए. Your teacher will train and students will be there, observer. Please do it. That will give you a lot of knowledge. Okay. Boron, I can do boron isotopic. This is my area. I have published many papers, and my technique has gone up commercial. We are getting money. 18,000 per sample in 2 minutes I can do. That's it. Recently I was thinking कोल एंड सीमेंट हो गया मेरा अभी 2 मिनट। कोल एंड सीमेंट, कोल क्वालिटी, सीमेंट क्वालिटी, कोल क्वालिटी whether it is good or not, कोल ash, उसका जो सिलिकॉन, एल्यूमिनियम, आयरन, कैल्शियम और टाइटेनियम, वो ash, after burning the coal there is a residue, जिसका रेसिड्यू कम है वो बेटर कोल है। Which is the better coal? Anybody can tell? Anthracite, then bituminous, then lignite, then bituminous। मेरा ऑलवेज ऐसा होता है, दो साइड से पहले बंद हो जाता है, ऐसा हुआ है। कोई कुछ कर रहा है, chemical scientist। So what I can tell, anthracite, क्या बोला, lignite, क्या? नहीं bituminous नहीं, lignite, then bituminous, then subbituminous। Indian coals are subbituminous, having coal ash content 31 to 46%. So I have done a method to tell the quality of coal. Also, in Bihar, one bridge 3 बार collapse हो चुका है, 2 बार। कितना पैसा जा रहा है? Because construction quality is very bad. The cement that is shown, the cement that has been used, very different. We are not blaming the contractor. So on site quality control चाहिए। There is a term called calcium to silicon। हो गया। First is switch off the light. So lecture stop. Take a break. Calcium to silicon, I am giving all funda today। ये ना पोर्टलैंड सीमेंट इज वेल नोन, इसका वैल्यू यही है। इसके ऊपर है बढ़िया सीमेंट, इसके नीचे है क्वालिटी कम। इवन देयर आर सीमेंट एट 0.5, 0.1 like that। My latest research is on forensic science। We got a very good research on IAEA। This is on there। हाँ, so I have got some classes। There are 10 brands of car, 48 classes were given। It is real classes from Israel Police through IAEA International। Our job was to tell, by taking the class, can you tell they belong to one particular car? It's not easy। So I was totally blank, then machine learning AI, we did the analysis, all classes are same। Glass is nothing but silicon, sodium, something, calcium, potassium, all are same, whatever the problem। Trace element, I found some transition element, all earth elements, they are different than one। Honda अलग है, Hyundai अलग है, Maruti अलग है। Again within Maruti there are many cars, very big job। So we did the work, the highest data was given by us। We published 10 papers, very good papers। One student got PhD, and my student is now scientist at Central Forensic Science Laboratory, Hyderabad। One post was there, he got। And our result was best result in the 18 laboratory of the world। Everything black box नहीं होना चाहिए। क्या कर रहे हो, कंप्यूटर में प्रोग्राम हो गया, मैं कर दिया, रिपोर्ट डाल दिया, क्या हो गया? Totally our program, our idea, fully our idea। This is not science। Your happiness should come from within। Certificate you should give। Who is a best doctor? A patient or a doctor? Patient knows कहाँ फेल हो रहा है। आपको आप बहुत कम इन्फॉर्मेशन देते हैं, फिर भी वो मेडिसिन दे रहे हैं, ऐसे ना? You know आपको क्या हो रहा है, you don't want to be admitted, so you are telling some lie and some medicine and घर जाके। So the patient is the best doctor। Like that way, you have to give certificate yourself। Never wait for a patent। Do some work unique। So आपको पढ़ना पड़ेगा, काम करना पड़ेगा, इंटरेक्शन करना पड़ेगा। ओके, उसको बोलते हैं दिल जान लगा के करो। Don't feel that I am deprived, I have no facility, इलेक्ट्रिसिटी नहीं है, मोबाइल मेरे पास तो एंड्रॉइड नहीं है, वो सब अलग बात है। Always find a way out. Do the best. Everybody can do the best. People think I am the lowest in the class, I cannot do. Better you go for some other job. Somebody may be good in computer, somebody may be good in sports. Sports भी चाहिए, पढ़ाई भी चाहिए. Okay? I am just finished. This is the work I did. This is my last slide. This is technology for all the things. Electricity industry technology and all. Everywhere. Right? Okay, thank you. Career opportunity here after tea. I have given career opportunity. What you can do by Dept. Please come, everybody. Okay.
I would now like to request the VDU sir to present the report of the R after
Students, with only 2 minutes break for the IT. You go and take the tea, and after that you come here, and after the tea break, actually you will listen the career opportunity in nuclear sciences. Not only in DRC, but also all over India and the world, where you will go and what type of jobs are waiting for you. So don't miss this class. Okay, go and take the tea and come back again.
Considero che no, Wonder la seconda, ¿verdad? Bueno, Wonder. Vamos a poner. Calma. Vamos fuerte, calma.
Sorry dita. Sorry dita, terlalu start করলে আমি